Welcome dear students in this video. Here heading in energy heads of fluid liquid. Actually, the fluid liquid has three types of energy: pressure energy, potential energy, kinetic energy. Now we name them in other way using Bernoulli theorem. From Bernoulli theorem, we know P plus half rho V square plus rho G H is equal to constant. यानी sum of three energy per volume at different points same. So now if we divide this equation by rho G or P upon rho G plus V square upon 2G plus H equal to another constant, एक fixed value होगी. These three terms, all these terms have dimension of length. Dimensions of length. Dimension of length, height, and these three terms are respectively called. These three terms are respectively called as pressure head, velocity head, and height head. All these three represent the energy, but they are given name and question are asked. So you can say कि pressure head क्या होगा? If someone say what is pressure head, so it is P upon rho G. Velocity head and velocity head V square by 2G, and height head equal to H, only height. If you solve, you will find the dimension of length. So this was something regarding this. I requested you to see some questions, application. I told you many applications. Now I want to solve some question based on Bernoulli theorem. And these questions generally may be asked in your class and exam if your teacher is very serious. Most of physics teachers are always serious, but students who pay attention get more and more. So here there is a question here, first one. A liquid is kept in a cylindrical vessel. Question है यहाँ पर. A liquid is kept in a cylindrical vessel which rotates. Here is the liquid. And this rotates about this axis. with certain angular velocity of, you are given the rate of speed of rotation is speed of rotation. Speed of rotation is equal to 2 RPS, revolution per second. Radius of the pipe is 0.05 meter. 0.05 meter. And you are asked what is this liquid rises here. So what is this height to which the liquid rises here? When it is rotated about the cylinder, rotated about this axis, then what is the difference in the height at the side and center? So along with the rotation of cylinder, the liquid also rotate, and here speed rotation 0. Here it will be maximum R omega, V equal to R omega, and omega equal to 2 pi n. 2 pi n. देखो यहाँ कंफ्यूजन क्रिएट करते हैं वो स्पीड रोटेशन एट 2 RPM. बच्चे इसी को ओमेगा मान लेते हैं. नो, इट इज n. ओमेगा 2 pi न्यू, तो 2 pi into 2 is 4 pi, and we need V, तो V equal to 4 pi into R, यानी 4 pi into 0.05. It is 0.2 pi. ये वेलोसिटी होगी. तो here point center O and P. If we apply Bernoulli theorem, and you know where speed is far greater, pressure is lower. So here pressure P1, it is P2, point P1. So P1 plus half rho 0 square. Here velocity 0 is equal to P2 plus half rho V square. We have applied Bernoulli theorem at point O and at point P side. So P1 minus P2 equal to half rho V square. P1 minus P2 equal to pressure here. So liquid rises to maintain same pressure, H rho G. P1 minus P2 half rho V square. Rho cancel. H equal to V square by 2G. V here we have determined it is 0.628 हो जाएगा. 0.628 है भाई. तो 0.628 square upon 2 into 9.8. And if we solve this, we get this height in meter इक्वल टू 2 सेंटीमीटर हो जाएगा नियरली. ये लगभग इसका स्क्वायर 39.39 कुछ आएगा, 0.39, एंड नियरली 19.6. तो मीटर डेसिमल में आएगा तो सेंटीमीटर बना देंगे. तो दिस इज वन क्वेश्चन हियर, ए गुड क्वेश्चन फॉर यू. नाउ आई कम टू अनदर क्वेश्चन हियर. There is always question based on Bernoulli theorem. Actually, in class 11, so statement and proof. Generally, teacher asks state and prove Bernoulli theorem in class 11 exam. But in competitive exam, they always ask numerical based on Bernoulli theorem. Here there is a question: water flows into horizontal pipe whose one end is closed with a valve, and the reading of pressure goes attached to the pipe is 5.5 × 10⁵ Newton per meter square. This reading of pressure falls to 10⁵ Newton per meter square. When valve is open, calculate the speed of water flow through the pipe. Pipe is like this. Here is some valve here. There is some valve here. So when valve is open, तो जो यहाँ प्रेशर था पहले बंद थी वाल्व, तो P1 actually they say it is equal to 5.5 into 10 to the power 5 Newton per meter square. Yeah, you can fit a wall here, sorry, not here. Wall is there. So when this wall open, pressure P2 becomes 10 to the power 5 Newton per meter square. So you are asked here, what is the rate of flow of water? Water flows into horizontal pipe whose one end closed with a valve and reading of pressure attached to this pressure gauge is 5.5 10 to the power 5. This reading of pressure gauge falls to 1.10 to the power 5 Newton per meter square when water open. So actually पहले जब वाल बंद थी पानी यहाँ रुका हुआ था, तो यानी कि यहाँ V1 बराबर 0, इनिशियल V1 बराबर 0, बट व्हेन ओपन सम वेलोसिटी विल बी देयर जो निकालनी है, तो वी अप्लाई P1 प्लस हाफ रो V1 स्क्वायर इक्वल टू P2 प्लस हाफ रो V2 स्क्वायर. V1 0 था और ये 5 इंटू 10 5.5 इंटू 10 to the power 5 था प्लस 0 इक्वल टू P2 ओनली 1.0 10 to the power 5 है भाई, और प्लस हाफ रो V2 स्क्वायर. I hope you have got my point. Water was to flow through this when this hand is closed. When this hand is closed, तो pressure here तो जब ये pressure है यहाँ पर liquid flow रुका हुआ है तो pressure is there, यहाँ पर 0. When this valve is open, the liquid start moving, तो pressure here itself here reduced to this. तो what is velocity? ये V1 V2 ही है, तो half rho V square is equal to this minus this 4.5 10 to the power 5. So V square is equal to it is 9 into 10 to the power 5 upon density of water, you know 1000 kg per meter cube. तो V square जो है V2 square equal to 900 और V2 equal to 30 meter per second. So without doing problem you can't understand what is the degree of difficulty. Please see video carefully, watch videos carefully, and then write the question and from the video and try to solve that. Now I come to competitive exam question. In 2015 there was a question in NEET. What is that? Wind with the speed of 40 meter per second blows parallel to roof of a house. यहाँ कोई हाउस है, यहाँ पर एयर फ्लोइंग with the speed of 40 meter per second. Wind blows at 40 meter per second parallel to the roof. This is the roof of house. Roof, the house is closed. Area of the roof is 250 meter square. 250 meters square is the area of this roof. So how much is the pressure created? How much is the force acting on this and individual? Density of air 1.2 kg per meter cube. Rho for air is 1.2 10 to power कुछ नहीं बस. So you are asked how much force. So air inside this is 0. V1 is this. So P2 plus half rho V2 square equal to P1 plus half rho V2 square. Here inside this pressure is 1 atm. So P2 minus P1 will be the difference of pressure is equal to V1. V2 is 0. This term becomes 0. Only left half rho V1 square. 1 by 2 into 1 by 2 into 40 square 1600. 0.6 decimal 0 960 Newton per meter square is the pressure difference. This pressure difference, because here pressure more than the outside, so force applied by this area into pressure, area 250 into 960 0 0 20 by 6 150 carry 15 225 10 4 2 240. So it is 2.4 10 to power 5 Newton vertically upward. यहाँ ऑप्शन दिए हैं डाउनवर्ड है अपवर्ड है, ये भी ध्यान देखना है आपने. तो एक ही क्वेश्चन होगा बड़े आराम से यहाँ पर. Bernoulli theorem always have question in every competitive exam. Now there is simple question again. A cylindrical tube of spray pump has radius R. ये हमारी ट्यूब है जिसका ये रेडियस R है. Now there are fine holes and fine holes and fine holes, each of radius R, each of radius R. If the speed of liquid in the tube be V, यहाँ पर V speed है water liquid, तो what is the speed of spray? With what speed the liquid will come out? So this simple A2 V2 equal to A1 V1. What is area A2 here? And fine holes pi r square. V2 we have to find out. A1 pi r square r into V. So here pi cancel. So V2 will come out V into r square upon n r square. This is the option here. This is the answer here. है भाई. तो somewhere we apply equation continuity, somewhere exactly Bernoulli theorem. So I hope you will be feeling good after getting some questions. In next video I will be telling you more questions. Thank you.